Good evening, everyone. I hope you guys enjoyed your 4th of July break. I have missed you so much. I am so glad that you guys are tuning in. And I know you're like, Miss Chris, why are we tuning in on a Tuesday? Well, I had a family emergency yesterday, which is why we are tuning in as of today. And so Mondays, Wednesdays, and Fridays, we will still be from 5 to 7 p.m., especially with my high schoolers. But now, since we're entering into the high school level, I want to get a little more in depth. So, what we're going to start doing now is adding in Tuesdays, and we'll do Tuesdays from 4:45 till about 6:30, 6:45, just so that we can get acclimated into that subject matter, because I really want you guys to understand and get the concept of Algebra 1, geometry, Algebra 2, and the pre-calculus with trig, okay? So, we are going to go ahead and get started. Also, I am still keeping our Saturdays. I may start Saturdays a little bit earlier just so we can have some extra time, because, hey, no time like the present for you to learn all things math, because everything math is very important. So, whenever you guys are ready, please click that like button, that share button, that thumbs up button. Whatever you got, please click that for me and let me know that you can hear me, and I promise you we can get started in Algebra 1. Thank you. All right, beautiful people. Look like a few of you have just now tuning in. So let's get started. All right, so the best way to start with algebra, start from the beginning. What is algebra? What are you being introduced to when it comes to algebra? All that good stuff. Algebra 1 is the perfect place to get started, okay? So, Algebra 1 kicks us off and starts us with evaluating expressions. What that means, we are introduced to variables. Variables are simply A, B, X, Y, R, S, T. Yes, variables are letters. But why would we need letters if we're doing math? Isn't math numbers? Yes, math is numbers. However, algebra is the math of the unknown, meaning you have to use letters in order to solve what you're looking for. So, evaluating the expression is basically finding out the unknown of your equation, because we're going to be evaluating, expressing, discovering, exploring. Algebra is the math that allows you to do all of those things. And the only way you can do that is with the letters. Otherwise, you're going to be adding, subtracting, multiplying, and dividing all kinds of numbers, never getting to the root or the solve of what you're looking for. So let's get started, shall we? So, what does evaluate expression looks like? First thing we have is multiplication. Multiplication will look like 3 different body types. It would either be 5 parenthesis n, 5 dot, or times n, or just simply 5n. With these expressions, know that you are taking the number 5 and you are multiplying it to the unknown letter. Now, next we have division. Division will look something like this. You'll have 14 fraction bar y or 14 over y, or you may have 14 divided by y, or you may even have y over 14, depending on what the number is. But know that division works these three ways. So 14 is being divided by y, or y may be divided by 14, but know that each place that you have the variable where the y is on the top, the y is on the bottom, the y is in the back, or the y is in the front, like that. Know that you are using these letters to solve for your answer. And that is how you would know that you are evaluating through division. All right, next up we have addition. Addition is simply put, either it's going to be C plus 6 or 6 plus C. And whether you write the C in the front, C in the back, whether you write C plus 6 or 6 plus C vertically, know that you are dealing with addition when you are evaluating the expression with a variable. So plus sign comes out, we're doing addition. Fair enough? Then, of course, you have last but definitely not least, even though it does give you the least, you have subtraction. Subtraction, of course, would be either, let's say, the number 8 minus x, or x minus 8, or you'll see something such as the difference of 8 and a number, or the number and 8. Now, if you see the word problem or equation and it says the difference of a number and give an actual number, it will be written like this. It'll be x minus 8. So say, for instance, it asks you to give the difference of a number and 8. That would be x minus 8. Now, if it says the difference of 8 and a number, then it would be 8 minus x. Also, if it just says minus, of course, that'll either be 8 minus x or x minus 8. But just so you know, whenever you see in the word problems, difference of the first letter or first number is what you put in as the first before you subtract, and then the second one. So the difference of 8 and a number is 8 minus x. The difference of a number and 8 will be x minus 8. Any questions so far? All right. Moving on. So now, how do we evaluate what I have been showing you, which is algebraic expressions or finding the unknown? Well, the first step is evaluate the number expression. Here's an example. When your letter actually equals a number, what does that look like? So what does it look like if I say 13n where n equals 3. Okay, so when you're dealing with 13n, 13n, if you remember at the beginning, means 13 times n. What is n? N is 3. So I'm going to substitute or change the n into a 3 because n equals 3. Therefore, I do 13 times 3. And of course, 13 times 3 is 39. Why? Because 3 times 3 is 9, and 3 times 10 is 30. 30 plus 9 is 39. Another example would be y over 8, where y equals 2. All right. Well, we know that y over 8 means we are dividing this number over 8. Now, since y equals 2, we are going to substitute or change y into the number 2. So that would make that 2 over 8. Now, this can be done 2 different ways. You can go ahead and do 8 with the 2 in the middle, or you can reduce your fraction like we learned at the beginning of simplifying our fractions with our greatest common factor. So that's 2 divided by 2, which is 1, and 8 divided by 2, which is 4. And of course, 1 over 4 or 8 divided 2 divided by 8, that will give us 0.25. And depending on the answer key, because it'll either ask you to leave it in fraction form or give it in simplified fraction form or give it as an integer or decimal. So in order to do so, all you have to do is either reduce the fraction if it asks for a simplified fraction, or give a decimal if it asks for a decimal. So evaluation expressions, simply put, all you are doing is substituting the letter with the given number that is equal to. Any questions before we move on? Also, I want to give a big, huge thank you to my little sister, Angel. She donated the algebra book that I am tutoring out of, and I am so grateful for it. I could not do any of this without the help of my community and the people that I love and love me back. So thank you, Angel. All right, beautiful people, we are moving right along. Next, we have read and write powers. This is just a recap of what we learned when it came to exponents that we did before we went on break. Remember exponents and the exponent rules? Well, how do we write power in words and as a product? Well, say for instance, I have 7 to the first power. Well, in words, of course, that would be 7 . to the first power and the product would be just 7 because 7 to the first power or anything to the first power, of course, is itself. Another example would be is something you're going to see really soon. Let's say you have z to the third. That would be z to the third just messing that whole thing up, huh? Let me try that again, this time with some feeling. Z to the third power. That is what you would have to write a power in words. And the product would be z times z times z, which of course will still give you z to the third. Any questions on how to write and read powers? All right, moving on to the next step. What do we have? We have applying order of operations, which is what we went through, I want to say either last week with the 7th and 8th graders, or we did that with the 5th and 6th graders. But nothing like a refresher. Shall we proceed? All right, here we go. Let's try this problem. 3 times 6 minus 4. All right, kids, let's put these thinking caps on. Order operation says we first must evaluate within parentheses. Since there are no parentheses, we shall move on. Next, we should evaluate or express an exponent, which we do not have because there's no number with a base and a power. Next, we would do the multiplication or division from left to right, whichever comes first. And as you can see, we have 3 times 6 at the beginning of the problem. So now 3 times 6, that gives me 18. And I bring down my minus 4. So now, once we have multiplied and divided from left to right, now we can do adding and subtracting from left to right, whichever comes first. So 18 minus 4, that gives me 14. Simple enough, huh? So now I'm gonna bring out a big boy for you, something a little bit doozy, but I promise you, you can get it. That's right, it's 14. All right, class, let's see if we can solve this one. 8 bracket 20 minus parenthesis 9 minus 5 close parentheses square closing out my bracket. Now I know y'all like, Miss Chris, what in the world is this? This is how algebra starts working itself together when you are learning how to add and subtract with the letters, and add, subtract, multiply, divide, and raise to a power with the numbers as well as the variables. So where do we start first? Well, we know that we start with the parentheses, right? Right. So since we start with the parentheses first, which parentheses do we start with first? Well, when it comes to double parentheses, you start from the inside and you work your way out. So, first thing we're going to do is evaluate inside of this parenthesis, which is 9 minus 5. I'm going to bring down my 8, my bracket, my 20, and my minus sign. And 9 minus 5, that gives me 4. And that is being raised to the second power. And then I close off my bracket. Okay, so far? Then we know that we're still within a parenthesis model. And within that parenthesis model, you still have to follow the order of operation, which is exponents, multiplication, division, adding and subtraction. So next we must do the 4 squared. So I bring down my 8, bring down my 20, and my minus sign, and then 4 to the second power, or 4 times 4, because 4 to the second is 4 times itself twice. And that leaves me with 16. Closing my bracket. Still moving along, still moving strong, shall we? Now you have 8 times, because 8 outside of a bracket means you're going to multiply. Uh-oh, looks like we have an answer already on the board. Right, 4 squared, 16. So now you have 8 times 20 minus 16. That gives me 8. Bring down a parenthesis. Now, whenever you get to a single digit within a bracket, it changes to a parenthesis. So now 20 minus 16, that gives me 4. And remember, when we said evaluating the expression, a number, parenthesis, another number, that means we're multiplying. So now 8 times 4, that gives me 32. Ta-da! Good job, everyone. Any questions on the order of operations? I see we have a question. Are parentheses used with single numbers? Sometimes. Sometimes they are used with single numbers. Earlier, as I mentioned, we had the 5 parenthesis n example. So, what does that look like? Say, for instance, n equals 4. So 5, 4, 5 times 4, that gives me 20. So, well, let me fix that because that looks like 2.0. And we want 20. So, usually when a single digit is listed in the parentheses, know that you are multiplying. Whenever you see the single digit, know that you are multiplying. Otherwise, if it's 5 parentheses 4 plus 3, then of course you would add the 4 plus 3, which will give you 5 times 7, and that gives you 35. Yay! Glad to be of help and service. Next, we have writing expressions. Guys, if you remember and you were tuned in through our elementary portion, you are going to definitely remember this. So, you remember order of my Operation Saturdays. Operation Saturdays, I gave you key words on how to recognize whether you're adding, subtracting, multiplying. This Saturday, we're going to work on dividing. So, here are some keywords for addition. Here are some keywords for subtraction. Here are some keywords for multiplication and keywords for division. So, addition. When dealing with a word problem, algebraic expression, here are some words that you need to look for. You have sum, plus, me and these butterfingers today, have plus, you have total, you have more than, and you have increased by. These are the words that you are looking for, and I'm sorry about the handwriting in advance. These are the words you are looking for when you are translating or rewriting or expressing an algebraic expression. So you're going to see things such as the sum of 2 and a number x. So the sum of 2 and a number x, simply put, is 2 plus x. Now, what if it said the sum of a number x and 2? That would be x plus 2. Always remember the number or letter that comes first, you write it first. Then the plus, the minus, or multiplied or division sign. Then you write the second number or letter last. Next, we have subtraction. Subtraction words, you will see difference, you will see less than, you will see minus, of course, and you will also see decreased by. Ooh, that looks horrible. Let me fix that decreased by. That decreased by was decreasing. Now, what does it look like when you do decreased by, difference, less than, and minus? An example would be the difference of a number n and 6. Simply put, that is n minus 6. Or you will see a number y minus 5. That would be y minus 5. Or you would see that 5 is being decreased by y. So that would be 5 minus y. Or you will see something that says 6 less than the letter H. That's going to be H minus 6. All right, next up we have multiplication. Multiplication, you have times, not tine, times, you have product, such as the product of, multiplied by, and of course the word of. Now, how can of be introduced or considered part of multiplication? Well, you'll see something like 1/3 of a number X. If you see something like that, know that you are dealing with multiplication, because all that means is 1/3 times X. So depending on what fraction it is, more than likely when you see the word of with a fraction, it does mean that you are multiplying and you're going to multiply. So 1/3 of, 2/3 of, 4/5 of a number X, a number Y, a number R. Anytime you see a fraction, the word of, and a number to a number X or 1/3 of N, if it's 1/3 of, you're multiplying. Fraction, the word of means multiplication, always. Also, you'll see something like 12 times a number Y. That's simply 12Y. Or you can do 12 parenthesis Y, or you can do 12 dot Y, whichever you prefer. But more than likely, you would want to do it like that one. Product of 6 and X. Simply put, 6X. Also, if you notice, whenever you are multiplying a number to a letter, the number always goes first. So whenever you are multiplying a number to a letter, the number always goes first. You never want to do N5 or Y6. The number, which is what we call the coefficient, it always goes before the letter, which is the variable. So coefficient, variable, coefficient times a variable, the number times the letter. Number first times letter second. $6K, exactly. Any questions? Last but definitely not least, even though it gets smaller or bigger depending on how you divide, is division. Probably would help if I don't spell division with a Z and a cursive Z at that. All right, division. That is the quotient. You also have divided by. You also have divided into. So now, quotient of a number K and 2. That can be written two ways. That can either be K over 2 with the fraction bar, or it can be, probably want to make my 2 look like an actual 2 and not a Z, or it can also be K divided with the division sign 2. And of course, it'll be either the quotient of a number K and 2, K divided by 2, or 2 divided into K. or K divided into two ways, depending on how the question is worded. But most likely you'll see the quotient of divided by and divided into. Any questions on the expressions? All right, we are moving on to writing equations and inequalities. What are equations? An equation is a math sentence formed by placing the equal sign between two expressions. An inequality is a math sentence formed by placing a less than equal to, a greater than or greater than equal to symbol between two expressions. So we have learned that expressions are 5n equals 35, or 2 times 3, that should equal n. Those are considered expressions. Expressions is, how do I solve this problem? How do I figure out the letter n? What is the unknown portion of this equation or inequality? So there are keywords that you must look for when you're dealing with these different symbols. Such as, you have the equal sign, which of course it means is equal to. Also referred to the same as. Example would be 5n is equal to 35, or 5n is 35, or 5n is the same as 35. Either way, you hear that, that means you will put an equal sign. Is definite. It's a statement. It means this is what it is. Period. So if the word is equal to, or the same as, if you hear those three phrases, know that you're going to put an equal sign between your two expressions. Now, if you have your expression, your two expressions, and the expression says 5n is less than or is fewer than, know that you must put only a less than sign. Now, dealing with inequalities, know that you are reading, especially when it's a single digit inequality, know that you are reading it from left to right. So 5n is less than 35. With me? So if you see is less than or fewer than, you are only going to put the less than sign. Next, which will probably be just an added step, the less than equal to. What you are looking for when you are doing less than equal to, you will hear is less than or equal to, or you will hear expressions such as at most or no more than. So 5n is less than or equal to 35. 5n is at most 35. 5n is no more than 35. That means your greatest number set is 35. And since the greatest number set is 35, that means the answer you are looking for has to be either 35 or less. So when it's 35 or less, that means you're doing less than or equal to. Next, we have greater than. Greater than symbol. That looks like a 7 more so than a greater than symbol. Let me try that again. So it should almost look like a bird beak or what they call a gator chop from left or right. Now, greater than symbol, you will hear the words such as is greater than or more than. So 5n is greater than 35. 5n is more than 35. So that means whatever n is, it will be greater than that number. So n should be greater than whatever we saw for n to be. Okay? Now, when you throw in that equal to sign, you get 5n is greater than equal to 35. You get 5n is at least 35. You also get 5n is no less than 35, which means 35 is my smallest number. So that means n is going to be bigger, is going to equal to or be bigger than 35 when I plug n in. So n should be greater than or equal to. N should be at least greater than or equal to, when multiplied to 5, 35. Now, if I solve this, n should be greater than equal to 7. Cool fact, whenever you are dealing with multiples of 5, if it ends in 5, it's odd. If it ends in 0, it's even. So if you multiply 5 times 2, 4, 6, 8, 10 and beyond, the number should end in 0, such as 10, 20, 30, 40, 50, 60, so on. Now, if n is odd, such as 1, 3, 5, 7, 9, 11, and so forth and so on in that manner, it should end in 5, such as 5, 15, 25, 35, 45, and beyond. So, if I solve this problem, all I'm saying is that n will be greater than or equal to 7, which means n should be at least 7, or n should be no less than 7 when you see greater than equal to. All right, here is an example problem of what we have been working on. So, verbal sentence. The difference of twice a number k and 8 is 12. So, the difference, meaning you're going to subtract, of twice a number k. Twice mean you're going to multiply 2 times the letter k. And the difference is between twice k, or 2 times k, and 8. So 2k minus 8, that is 12, which means it equals 12. So, if you are reading your sentences, this is what it would look like. So, if, like it said the difference of, immediately I know I'm subtracting. When you see difference of, know that you're getting ready to subtract either 1, 2, you subtract 2 or more things. So, difference of twice a number k. Twice a number k, simply put, is 2 times k. When you see twice, 3 times, double, triple, those words to a letter, you are multiplying that number to that letter. And it goes first. Had it been the difference of 8 and twice a number k, then that would have been 8 minus 2k, and is 12. It would still equal 12. So keyword is. Is, of course, mean we are saying equal. Is equal to, the same as. Those 3 words, I am putting an equal sign. Another example would be the product of 6 and a number is at least 24. So now, the product of a letter and a number means I'm getting ready to multiply the letter and the number. So that'll be, since we had 6 and n, that would be 6 times n, or 6n. At least, where did we hear the at least? What symbol did we use for at least? Greater than, equal to. So, at least means I am saying greater than, equal to, and it is the number 24. So, at most, well, at least, your smallest number, when multiplied to 6, should be 24, or is greater than 24. Also, you're going to see something really handy that I think is really neat. Say, for instance, you have a number y, and it is no less than 5 and no more than 13. So that means y should be in the middle, right? Because no less than, that means y is greater than equal to 5, and no more than is less than equal to, so that means y is less than equal to 13. So if you put these three together, it will look like 5 is less than or equal to y, because y is greater than equal to 5, and also y is less than equal to 13. So anytime you have a greater than and a less than, greater than equal to, less than equal to, and you see some interchangeables of those sort, if you have both of them going together with the same letter, you can write it like this. Another example would be if a number y is no more, a number y is fewer than 2. So that means, wait, let me get my bearings. Y is more than 2. So that means y is greater than 2. And then y is at most 15. So that'll mean that is y is less than or equal to 15. What would that look like? So your problem is y is more than 2 and is at least 15. Well, at most 15. Correction. Y is greater than or more than 2. Y is also at most or no more than 15. So that means 15 is my biggest number. 2 is going to be my smallest number. What does that look like if I rearrange and write it? It will simply look like 2 less than y less than equal to 15. So if you notice, the greater than switches over to a less than when you are writing it into an inequality expression. This is what I call an inequality expression. So anytime you're writing an inequality expression, know that the greater than one goes first and it is flipped to less than, so it can read from left to right that 2 is less than y because y is greater than 2. And then y is greater than equal to 15. Any questions? All right. Do you guys know we just went past chapter 1 of Algebra 1? Good job. Any questions on chapter 1 before I move on to chapter 2? All right, beautiful people. Chapter 2. Chapter 2, we are discussing whole numbers, integers, rational numbers, irrational numbers. Basically, we are defining what numbers are. So first, we must define them as real numbers. All numbers, whether rational or irrational, are real numbers. You have the rational side, you have the irrational side. But remember, real numbers, all of them, all numbers, negative, positive, rational, irrational, all numbers are real numbers. And the reason why they're talking about real numbers is because soon you will learn something called imaginary numbers. But that's far along down the line, around Algebra 2. But we must first focus on real numbers. What are real numbers? Real numbers are broken up into two categories. You have the rational and you have the irrational. Now, what does a rational number look like? Well, a rational number is a whole number. A rational number is an integer. And a rational number is a natural number. What does a natural number look like? Naturals and whole numbers, they are the same. That means both of them are positive. Now, also when it comes to rational numbers can be decimals. But in order for it to be a decimal, for it to be a rational number, two things must happen if it's a decimal. It must have a stopping point, like 0.25, or it must repeat a pattern forever, such as 0.3333, or that can be written as 0.33. With a bar over it. The bar simply means it's repeating forever the same pattern. Repeat forever the same pattern. So you have rational numbers, which are whole numbers, integers, natural numbers, which is the same as saying, which is the same as saying whole numbers. And you also have decimals or fractions, whichever, that must either be a stopping decimal, means it has a finite number. It does not go on forever. And if it does go on forever, it is a repeating pattern that goes on forever and ever and ever and ever. Now, irrational, simply put, not a whole number. It are decimals. And the decimals go on forever and they don't repeat. So you see something like pi. Pi, as we know it, is reduced to 3.14, or its fraction form is 22/7. So usually you'll see pi as 3.14, or soon you'll see it as 22/7. Now, that is a cute form of this number. However, pi is irrational, meaning it goes on forever and it does not repeat itself. There's no repeating pattern in pi. Same thing goes if you have a square root or any root that doesn't divide out evenly, like the square root of 2. Square root of 2, that falls between the square root of 1, which is 1, and the square root of 4, which is 2. Since those are whole numbers, those are considered rational. What makes it irrational is because it falls in between squares, such as the square root of 2, the square root of 3, the square root of 3.5. Anything that has a non-repeating pattern, that is considered irrational, not a repeating pattern, and it's going on forever. Really, you basically see no end in sight with these numbers. Any questions on real numbers, the rationals, the irrationals? Any questions, anyone? Cool beans. Moving on. So now that you know the difference between rational and irrational, you can add real numbers. You can add real numbers, you can subtract real numbers, you can also multiply and divide real numbers. So what does that mean? What does that look like? Say, for instance, you have 5 plus a -1. You want to know another way of writing this? 5 minus 1. Now, how can I go from 5 plus a -1 to just 5 minus 1? Well, the plus sign is being multiplied, or has an understood 1 that is being multiplied to the -1. And of course, a negative times a positive is negative. So since a negative times a positive is negative, I simply can say that 5 plus a -1 is 5 minus 1, which of course is 4. Now, say for instance, we wanted to do this on the number line, and you're at the number 5, and either you are going to go to the left 1 or to the right 1. Now, when you are adding a -1, know that you are going to the left 1. Adding a negative means you're going to the left. Adding a positive, you are going to the right. Adding negatives to the left, adding positives to the right. So now 5 plus a -1, that's going to land me at 4. Whereas if it was 5 plus a +1, which would have simply just been 5 plus 1, that would have landed me at the number 6. So anytime you are adding negatives, know that you are basically subtracting them from that number. Also, always remember opposite signs, you subtract them and you keep the bigger number. We talked about this earlier on, but let's refresh about it. Whether you have -7 plus 5, or if you have 5 plus a -7, which of course would still be 5 minus 7. All of these answers are going to be -2. The reason being, when you have opposite numbers, you subtract them from each other. If you have a negative and a positive, you subtract them from each other, especially if you have a plus sign in the mix. If you have a plus sign in the mix and you have a negative number and a positive number, you are subtracting them from each other. Once you subtract them from each other, you keep the sign of the bigger number. So -7 plus 5, 5 plus a -7, or 5 minus 7, all of those are still going to be -2. Why? Because once you subtract them from each other, the biggest number is the sign you keep. Now, say for instance, I switch my stuff around and I do -5 plus 7, which would be 7 plus a -5, which is also 7 minus 5. Each of those answers are going to turn out to be a +2. Why? Because they are different signs. Different signs you subtract, and once you subtract them, you get the sign of the biggest number. Since 7 is positive, the 2 must be positive. Now, the only thing you're going to see that changed up a bit is when you are subtracting negatives, or you're subtracting 2 negatives from each other. Such as if you have a -7, probably want to make that a 7 and not a Z. -7 minus a -4. You remember my rule when I had the understood one for the plus? Well, there's an understood one for the negative. So -7, -1 times a -4, of course, that makes that positive, which makes that a +4. -7 plus 4, that equals a -3. Now, another way is -7 minus 4. Now, as you can see, -7 is minusing a +4, or you're going to the left further 4 times past the -7. So, if you have -7 minus 4, that's going to give you -11. The biggest difference between these two, one has a parenthesis, one does not. One also have double negatives, the other one does not. So when you are dealing with negative numbers, notice that if it has a double minus sign or a single minus sign, you're going to add the numbers together. Double minus sign, you're going to subtract the numbers from each other. Because the double minus means that becomes plus, and of course, plus a negative, if the negative is bigger, it's going to remain negative. Any questions on the adding and subtracting these integers? All right, beautiful people. We are going to move on to distributive property. If you remember, I mentioned distributive property last week before last. So, what I said, distributive property would be best used for when algebra. And this is why. Say, for instance, you have 4 times y plus 3. Distributive property says I must multiply the 4 times the y, and I must multiply the 4 times the 3, and that gives me my product of 4y, which is 4 times y, and 12, which is 4 times 3. Next, if I decide that I want to, and of course this all applies to if you're doing subtraction as well. Same rules apply. You just put it inside, and you put this number inside of the parentheses. So, say for instance, you have parenthesis 2 minus n, and the 8 is in the back, or the 8 is in the front. Always remember, if you remember, Associative property, where it's in the front or in the back, you're going to get the same answer. So distributive property says I'm multiplying it to the 2 and I'm multiplying it to this n. So that's going to be 8 times 2 minus 8 times n, which gives me 16 minus 8n. So all you have to do when it comes to distributive property is remember, you're taking the outside and you're multiplying it to the inside. Any questions on distributive property? All right, we will move on. Oh my gosh, guys, we are in chapter 3. See how time flies when you having fun? We are in chapter 3. All right. Let's get to moving on, shall we? So now, in chapter 3, you are learning how to solve step equations. Remember that equal to and greater than, less than, greater than, equal to, less than, equal to sign where I had 5n equals 35? Remember those? That is considered a one-step equation, meaning you only have to do one step to solve it. Same thing as if you have x plus 7, that equals 4. You only take one step to solve this equation. So how do I first solve? Let's start with x plus 7 equals 4. So x plus 7 equals 4. How do I find this answer? Well, when you're solving equations, you do the complete opposite of what you are solving for. So if x is being added to if 7 is being added to the x, in order to get the x by itself, you must subtract 7 on both sides of the equal sign. So you're going to subtract 7 from the 7 and 7 from the 4, because the goal is to get the letter by itself, because now we're in algebra expressions of solving them. When you're solving an algebraic expression, all you have to do in order to solve it is get it by itself. And basically, when you get it by itself, you're doing the backwards version of PEMDAS. And this is how I explain it when I say the backwards version of PEMDAS. So if I'm adding 7 to the x and it's equaling 4, to solve for x or to find out what x is, I must subtract 7 on both sides. So I'm going to bring down my x. Now you can do this 2 ways. Whichever way you prefer is all on you. But 7 minus 7 plus 7 minus 7, you can either cross that out or you can say plus 0. And that equals 4 minus 7. Well, 4 minus 7 is a negative 3. Remember, subtract numbers that are of course not alike because you have a positive 4 and a negative 7. So 4 minus 7, that gives me negative 3 because 7 is negative, therefore my 3 must be negative. So now x plus 0, anything plus 0, identity property or rule is x or itself. And so x equals a negative 3. Now, say for instance, instead of x plus 7 equals 4, I end up doing x minus 7 equals 4. What do I do if I have x minus 7 and it equals 4? Just like if 7 was being added to x, I subtract 7 on both sides. Well, if 7 is being taken away from x, I am going to add 7 on both sides. So that would look like plus 7 here and plus 7 there, because the goal is get x self. So for me, I would bring down my x, cross out my 7, plus and minus, because plus and minus, that gives me my 0. And for those who just have to have their 0, plus 0 is what you would put down here. And we would say equal, well, 4 plus 7, that is 11. And of course, x plus 0 is still x. And that equals 11. This is how you solve one step if you are adding or subtracting. Any questions? All right, we shall move on to multiplication and division. What does that look like when we're solving? Well, you have 5n equals 35. Remember my handy dandy problem? Well, if I am multiplying 5 to n, because 5n is simply saying 5 times n. How do I get n by itself? Well, the opposite of multiplication is division. So now 5n will have to be divided by 5. You are dividing only the number. Do not divide the number and the letter. The reason why you're not dividing the number and the letter, because the letter is what you're looking for. It would make no sense if you divide the letter and the number, because you're looking, solving, wanting to know and explore exactly what is n going to equal. So now 5 divided by 5, you can either cross the 5s out like this, Or you can just say 1n, which of course would be 1 times n. 1 times n equals 35 divided by 5. That will give me 7. So then 1n, which is 1 times n, anything times 1, identity rule is itself. Therefore, n is 7. Now, when you have equations like this, there are going to be two ways this happens. Sometimes this will be the multiplying number would be positive, and well, the multiplying number will be negative, and the answer will be positive, or the multiplying number will be positive and the product will be negative, or both of them will be negative. The product as well as the number that is being multiplied to the letter. Guess what? Whatever you're dividing by on the left, you must divide by on the right. So if that is a negative 5n, you are dividing by negative 5. The reason why you are dividing by negative 5 and not just 5, because your n must become a positive 1. All of your variables, they must be positive in order to solve for that variable. If you only divide by 5, that means n is going to be negative. Therefore, you have to divide by negative 1. And that makes this less. This makes this more than a one-step equation. So negative 5 divided on both sides. Five divided by both sides. And of course, again, negative 5 divided on both sides. So now, if you're dividing a positive to a negative or a negative to a positive, your answer is going to be negative. So 35 divided by negative 5, that is a negative 7. Negative 35 divided by 5, that is a negative 7. Now, if you have a negative divided by a negative, it is going to be a positive. The reason why it is positive is because negative times negative is positive, so therefore negative divided by negative is positive. Negative divided by negative times negative times positive is negative. Therefore, a negative divided by a positive is negative. Or a positive times a negative is negative. Therefore, the opposite effect is still negative. A positive times a negative is negative. Then a positive divided by a negative is negative. So, great rule of thumb when you are dividing. If they are opposite signs, they're negative. If they're same signs, they're positive. Whether it's negative and negative or positive and positive, your answer is going to be positive. But if it's a negative and a positive, whether it's the first number or the second number switching back and forth, both of them are the answer is going to be negative. Any questions on the one-step solution? Oh, one more thing. Say Say, for instance, you're solving for a division equation. You can do this two different ways. You can either cross multiply because there's an equal sign between the two, or you can multiply by the denominator. So if I multiply by the denominator, that lets me know that n and n, that gives me, because I'm crossing out my n's. If you multiply by n, you can cross out the n's because n in fraction form is understood over 1. So now n times 35 over n, that gives me 35. And of course, that is 5n. Now, division takes us into a two-step equation. Why? Because it takes about 2 steps to do this. So then you have the 35 equals 5n. And of course, you divide by 5 on both sides. And n equals 7, or 7 equals n. Any questions of what we learned for today? Any questions? I'm here to help. Yes, that is correct. Same symbols equal positive, opposite symbols are negative. So, positive times positive, negative times negative, they both will be positive. Positive times a negative, or a negative times a positive. Both of those will be negative. And the same rule applies if you're dividing. So positive times positive, positive divided by positive. Negative times negative, negative divided by negative. They both should be positive. Positive times a negative, positive divided by a negative. Negative times a positive, negative divided by a positive. Both will be negative. Any more questions? All right, you beautiful, wonderful, amazing people. This is where we will stop for today. Right now, we're still in the middle of chapter 3, and we're just going to continue on till we finish this book, okay? So, Algebra 1, this is what we are working on. I will be working on with you Wednesday. I'll be working with you on Friday, and I definitely will be working on algebra on Saturday, along with division. That is the operation that we did not cover before break. So, covering operations, Operation Saturday with division, and we will be covering the rest of our Algebra 1 book. Now, after that, next week we'll have geometry. After that will be Algebra 2. And then after that, or Algebra 1 Part 2, because Algebra 2 is the same thing as Algebra 1, just a few more equations and formulas. And then after that, we will work on calculus. And then, of course, by then, we should be getting ready to go back into school and get ready to learn and grow together. So, if you have any questions, know that you can inbox me, know that you can DM me, know that you can text or call me at 205 542 5062, 205 542 5062. Also, this does not have to be strictly to high schoolers. For those who want to advance in their learning and love math like I do, you can introduce your children no matter what age they are. Let them learn about algebra because they're already learning about algebra starting in kindergarten. Algebraic equations are already being implemented. What better way to further educate them on what they are learning by letting them see these videos? So, of course, if you have any questions outside of the live, you can IM me, DM me, or text me at 205 542 5062. My name is Miss Chris. I hope you had a terrific, just amazing Tuesday. May your day be blessed, may it be longer, and may you prosper in which you are sent. I'm Miss Chris of Mathematics for You Tutorial Services, where we are changing mindsets one problem at a time. Have a blessed evening, and I'll see you tomorrow at 5 p.m. Good night.